Hello, dear students. I am Aditya Gupta, and a very warm welcome to this third lecture on the topic of pair of linear equations in two variables. Now, in this particular, earlier we have completed three methods like substitution method, cross multiplication method, elimination method. Now, talking about this lecture, what we will be doing is that. The topics of consistency of system of equations and graphical method of solving we will be looking at, right? So let's get started. And one thing I would like to tell, consistency we have already seen from the perspective of cross multiplication method, but we'll be understanding it in greater detail along with graphical inference. Okay, what we can infer or conclude from graph as well. So let's see what we mean by consistency. A system of two linear equations can have exactly one solution, infinite number of solutions, okay, or it can have no solution, right? So let me just write it a little bit clearly here. Infinite solutions, okay, or no solutions. So basically, when we are talking about a pair of linear equations in two variables, it can either have exactly one solution, which is also called unique solution. Exactly one solution means, for example, x comma y equal to 3 comma minus 5. This is exactly pair of one pair of solution, right? One solution for x and y. But sometimes there are infinite solutions also, or it can have no solution. Apart from that, apart from these three conditions, nothing else can happen. For example, it can't have exactly two solutions. That is not possible. It can't have exactly three solutions. That is also not possible. The only possibilities are exactly zero solution, which means no solution, exactly one solution, which means unique solution, and infinitely many solutions. These are the only three possibilities. Now, systems of equations can be classified by the number of solutions. So if the system has at least one solution, it is said to be consistent. So if a consistent system has exactly one solution, it is independent. Okay. So the reason why it is called independent is because if it has exactly one solution, which means that it has a unique solution, then it is called independent. But it will be called dependent if it has got not exactly one but infinitely many solutions. The reason it is dependent is because the second equation is dependent on first equation itself. For example, okay, this we'll see later. Right now you might not be able to understand, so let us read the third point here. If a consistent system has infinite number of solutions, then it should be a1 by a2 equal to b1 by b2 equal to c1 by c2, as we have already seen in cross multiplication method, right? So I told you there also that for infinite number of solutions, this condition should hold. When you graph the equations, both represent the same lines. So of course there will be infinite number of solutions. Okay. Now look, in these diagrams also, these are dependent consistent system. The reason they are dependent is because here they are infinite solutions. So graphically they represent the same line. Now you might be thinking what we mean by graph. So this we'll see later, don't worry. But right now we need to understand that as far as consistent systems are concerned, it should have at least one solution. It means that either exactly one solution or infinitely many solutions. Both come under a consistent solution only because both have at least one solution, correct? And no solution means inconsistent system, correct? So when we are talking about consistent, it covers unique solution case, one solution case, and infinite solution case, but not no solution case. Okay, because it should have at least one solution. Okay. Now, infinite solutions, for consistency, we have seen that for infinite number of solutions, this should hold, and for exactly one solution, we have already seen that this should hold. Okay. This is for unique solution or exactly one solution. Okay. So these are a few things that we should be aware of. Now let's see about inconsistent system. So what happens for an inconsistent system? A system of two linear equations can have one solution. Okay, this we have already seen. Right now, if a system has no solution, it is said to be inconsistent. That's the definition. The graphs we will talk about later also, don't worry. Algebraically, we have already discussed this also using what? Using cross multiplication method. We have already seen this condition that this should hold for inconsistent, inconsistent system where there is no solution. This we have already seen in using, cross multiplication method. Okay. Now, so algebraic conditions, we should know that this is the condition for no solution or an inconsistent system. For consistent system, there are two subparts which I have already discussed in, using cross multiplication as well. First was unique solution, in which this should hold true. Second is maybe there are infinite solution for which this is true. Okay, fine. Now let us have a look at this question. Check for the consistency of the following pair of equations. So maybe you can write this like this: minus x plus 2y plus 1 equal to 0. And maybe you can write this like this: minus 2x plus 4y plus 2 is equal to 0. Easily you can observe a1 upon a2 equal to b1 upon b2 equal to c1 upon c2, because all of them are equal to half. This means that there will be infinitely many solutions. Many solutions, okay? So that's how we are able to prove that it will have infinitely many solutions. Since it has got infinitely many solutions, clearly it will be consistent. Yes, it is consistent. Due to infinite solutions, okay? Infinitely many solutions. That's what we are saying. And of course, here also answer we are getting the same, that indeed they have infinitely many solutions, they are consistent, and of course they are dependent because they are having infinite number of solutions, whereas for unique solution it used to be independent, right? So graph we will talk about in just a minute. Okay, don't worry. But right now, algebraically, we should understand how we can find whether a system of equations is consistent or inconsistent. And if it is consistent, then which part is it, unique or infinite solution, right? Now, talking about graphical method, a linear equation in two variables, when plotted on a graph, defines a line. Such an important point. This is a very important point. What we are saying here is that whenever we are talking about ax plus by plus c equal to 0, so this linear equation, when plotted on a graph, always represents a line. This is a very surprising fact. This is not obvious by any means, okay? We cannot take this for granted. In fact, in class 11th, you will actually prove that this always represents a straight line. But for right now, let us just make use of the fact without proving only. So right now you have to remember this fact that this always represents a line. As long as A, B, C are any real numbers and A and B are not simultaneously 0, which can also be written in this way. Okay. So both should not be 0 at the same time, because if A and B are 0, then C will also have to be 0. If all of them are 0, it doesn't make any sense. Okay. So at least one of A or B should be non-zero. Then this will always represent a line. This is such an important thing. Now, what do we mean by plotting a graph? So let us understand that. Look, please understand, whenever we are given any equation involving x and y, then any x comma y which satisfies this equation will lie on the curve on the graph. Okay, curve and the graph are the same thing. Graph is also called the curve. Okay, so any x comma y which satisfies this equation will lie on the graph, and any point that lies on the graph will satisfy this equation. Such an important point I have told you. Okay, so for example, let us take some random example. Y equal to x square, let's say. So obviously 0 comma 0 satisfies this equation, so it will be here on the graph. 1 comma 1 also satisfies, yes. So 1 comma 1 point is here. Then similarly, half and 1 by 4 will also satisfy. Similarly, minus 1 comma 1 will also satisfy, because easily you can see this equation is satisfied by the point x equal to minus 1, y equal to 1. So this point will also be there. Similarly, minus half 1 by 4 will also be there. Similarly, 2 comma 4 will also be there. So you can easily see that if you join these points appropriately, you will get a graph that looks like this. Okay, such kind of a graph you will get. So this is kind of the shape that we are getting. Okay, sometimes you can also get this kind of a shape. So different shapes we can get, but whenever it is a linear equation, it will always be a straight line. Are you getting my point? So I will also help you understand this, let us say, with the help of an example. So let me take an example here itself. I will just erase this graph for y equal to x square. And now let us talk about the graph of a linear equation. Okay, so this is the graph of this thing. Okay, now talking about a linear equation, let us take an easy example. 2x plus y is equal to 5. Okay, now easily you can see there are so many solutions to this. For example, when x is 0, y is how much? 5. When x is, let us say, 1, y is coming out to be 1. No, 3. When x is 2, how much is y coming out? 1. Then when this is minus 1, it will be x, x will be 3. So if you try to plot all of these points, look how it will look like. 0 comma 5. 0 comma 5 will be here somewhere, right? Then 1 comma 3 will be 1 comma 1 and 3. So 1 comma 3 will be here. Then 2 comma 1, 2 comma 1 will be here, 2 comma 1. Then 3 comma minus 1, 3 comma, okay, and let me mark these. Uh, Although I don't think I've drawn a good enough graph, but anyway, you get the point, right? So 3 comma minus 1, okay. So if you join all these points, you will find that they lie on a straight line. Okay, these all of them will lie on a straight line. You can actually try this yourself. Take a graph paper, make the coordinate axes, mark the points 1 2 3 4 minus 1 2 3, okay, on both the x and y axis, and actually try to mark these points and then try to join them by a straight line. You will be surprised that indeed you are able to join them using a straight line. Okay, so now that we are clear about this representing a straight line, what can we say? That this means that whenever a pair of linear equations is plotted, two lines will be formed. Obviously, because two linear equations means if we want to plot the graph of both of them, two lines will come on the graph paper, right? So two lines will be plotted. There are only now there are two lines in a plane. So there are only three cases. Either they can intersect each other at a point, or they can be parallel to each other, or they can be coincident lines, the same lines basically, right? One over the other. Apart from these, obviously there are no other cases. Either they will have to intersect, or they will be parallel, or at the max to max they can be coincident lines. Okay. Apart from this, nothing can happen, as is clear from the study of Euclidean geometry also, correct? Now look, we now have a few conditions. First condition, intersecting lines. Obviously, wherever they will intersect, whichever point they will intersect, that will be the solution. The reason is that if you have drawn two lines, okay? Now look, please understand carefully. If they are intersecting at a point P whose coordinates are A comma B, then what does it mean? It means that A comma B, since it lies on the line L1, okay, this is line L1. Since this point lies on the line L1, it will satisfy the equation of the line L1, because I already told you what do we mean by a graph? Any point that lies on the graph will satisfy the equation. Any x and y which satisfy the equation will lie on the graph. Both way it holds true. I already told this. So since this point P lies on L1, obviously when I put x equal to A, y equal to B, the equation will be satisfied, right? Similarly, since Okay, just a second. Yeah, I hope you all are now getting the point, right? So look, since P point also lies on the line L2, so the coordinates of these points x equal to a, y equal to b will also satisfy the equation of line L2, and hence it is obviously a solution then. The reason is that it is satisfying this point A and B. They are satisfying both line L1 and L2's equation. So that's why it will be the solution of the two equations as well. Correct? So basically, this is the equation of line L1. This is the equation of line L2. When we will plot them, we know for a fact that on the graph it will be straight lines, two straight lines, right? And we have also proven that the point where they intersect will be the solution of both the equations, correct? So in this case what happens is that they have a unique solution, the lines are intersecting, and from our study of you know uh, cross multiplication method, we also know that for a unique solution case, a1 by a2 must not be equal to b1 by b2. So what can we say? That whenever a1 by a2 is not equal to b1 by b2, for sure it will represent intersecting lines. Such an important thing. Whenever a1 by a2 is not equal to b1 by b2, the lines will surely be intersecting. This also we can conclude. Now, coincident lines. What can we say here? So what, look, both of these lines here in this diagram are coincident, exactly one over the other, right? So what happens in this case is, look, obviously if both of these lines L1 and L2 prove to be coincident, then it is so clear to us that if you take any point, let's say point A comma B, then obviously this will be a solution here because it satisfies line L1 also and line L2 also. Similarly, you take another point B whose coordinates are C comma D, then this is also a solution because C comma D lies on L1 also. So L1 will also be satisfied. L2 also it lies on. So its equation will also be satisfied. So this is also a solution. So there can be infinite set points, right? Which you can take. So we gather that whenever there are infinite solutions, the lines will surely be coincident, correct? So in the case of coincident lines, there will be infinite solutions. In case of infinite solution, there will be coincident lines. Both way it is true. And from our study of what? Cross multiplication method, we already know that for infinite solutions, this case should hold true, right? Whatever is written here, a1 by a2, these ratios are equal to each other, right? So we can conclude that whenever this will hold true, the lines will be coincident. Okay. So I hope this case is also clear to everyone. Now let us talk about the case of parallel lines. So in case of parallel lines, what happens is, look, please understand carefully. If the lines happen to be parallel, then clearly they will never meet each other. They will never meet each other. And if they are never meeting only, then there is no such point which satisfies both of them. Because if there were to be a point which satisfied both of them, then it should have lied on both the lines, which means at that point at least the line should have intersected. But we know for a fact that parallel lines never intersect, so it cannot have a solution only. So what we are saying is that if we plot the line L1, plot the line L2, and they turn out to be parallel, then obviously there will be no solution, because they are never meeting only, they're never intersecting only, they don't have any common point which satisfies both of their equations. So clearly what we conclude is that in case of parallel lines, there will be no solution, and in case of no solution, the lines will be parallel. Both way it will hold true. Okay. And from our study of cross multiplication method, we already know that a1 by a2 should be equal to b1 by b2, but it should not be equal to c1 by c2. So we can say that whenever this will be the case, the lines will be parallel. Okay. All three are simultaneously true. Any one of them is true, then the other are true. If the lines are parallel, then this condition will hold true, this condition will hold true. No solution and this ratio thing will hold true. If there is no solution, then this will hold true, this will hold true. Parallel lines and this ratio thing. If this is true, then no solution thing and parallel lines will. So out of these three, any one of them is holding true, then the rest of the two will automatically hold true. Okay. This is the essence of these three conditions. This is the most important takeaway from these conditions that we have learned. Here also the same thing. Even if one of them is given, the rest of the two are automatically true. If someone tells you infinite solution case is there of these equations, then automatically you can be sure that the graph will be coincident lines and this condition will hold true. If someone tells you that this is holding true, then you can automatically be sure coincident lines there will be and infinite solutions there will be. If this is given true, then you are getting the point that out of these three conditions, anyone holds true, the rest two automatically hold true. Similarly for intersecting lines as well. Now let us talk about this system, solving graphically and identifying the type of system. So look, fine, let us try to draw the graph. Now look, please understand what I'm saying carefully, that since I already know that I already know this will represent a line, right? So to draw a line, minimum how many points we require? 2, right? More than 2 also we can take if you want, 3 points, 4 points, but even 2 will be sufficient, right? So write this equation in this fashion and then make x comma y which satisfy this. So when x is 0, y will be -8, it satisfies this. Then when x is, let us say, or let's say when y is 0, how much is x? X is -4. So these 2 points, how can we mark? 0 comma -8 is, let's say, here. Okay, so you should take a graph paper with yourself and then try to draw all of this. Right now I am just drawing on the white sheet only, but you should draw this on a graph. Otherwise you won't be able to solve it. Okay, so 0 and -8. Now where is the point? -4 comma 0 which satisfies this equation? It is here, -4 comma 0. So obviously, since I know that the equation will come out to be a straight line already, because this is the first thing that we learned, right? That this represents a straight line always. So I can just join these 2 points like this. Okay, using a scale, of course. Right now I'm just drawing freehand, but in actual graph paper you will use a scale to draw this straight line. Okay, now what about this? You can write this in this manner: y is equal to x plus 1, right? Now what x and y satisfy this? You can just take 2 points, or if you want you can take more than that also. It is your choice, no problem. So when x is 0, y is 1. When x is 1, y is 2, 2, 3, right? So here I have taken 3 points, but 2 points also are sufficient. But if you want, you can take 3 also, more than that also. So where is 0 comma 1? 0 comma 1 is here. Then where is 1 comma 2? 1 comma 2 will be somewhere here. Correct? So 1 comma 2. Then where is 2 comma 3? 2 comma 3 will be here, 2 comma 3. So basically when you will join these points, you will find that they are easily seen to be intersecting, and whatever the point coordinates of this point come out to be will be the solution of our question. So identify the type of system. It is consistent system with unique solution. With unique solution. Why? Because these are intersecting lines, right? So unique solution. Okay, and whatever on the graph paper, whatever coordinates you find of this point will be the solution. So in our solution also, we can easily observe that when we draw these graphs properly, this point comes out to be -3 comma -2. So that's our solution. X is -3, y is -2. That's it. That will be the answer. Okay. So, okay, independent system, yes. Unique solution was also called independent system, as we have already seen. Okay, so that's pretty much it. That's how we'll solve this question. Okay. And I hope this is clear to everyone how we drew the graph. Look, this point we identified -4 comma 0, right? 0 comma -8. Here also we can identify the point, let us say the point 0 comma 1, 1 comma 2, and then join them to form a straight line, right? So easily, I hope everyone has been able to understand this question. Okay. Now, let us have a look at some of these good practice questions So we have these two equations, right? And this also. Let us solve the third question. It seems interesting because we also have to identify the type of system, right? So there are multiple ways, right? Like we can use whatever method we wish, but let us use graphing method since in this lecture we have been following graphing. Otherwise, we can simply use any other method. We can simply use cross multiplication method to identify the type of system as well as the solution itself. But since right now we are focusing on the graphing method, let us see how to draw this particular line. So let's see, when x is 0, y comes out to be 4. When y is 0, x comes out to be 10. So just mark these 2 points, for example. 0, 4 is here. And where is 10, 0? This point is somewhere here. 10, 0, right? X-axis and y-axis. Now, if you join them with a straight line, you will get the equation, right? You will get the graph of this equation. What about this? Maybe first you can simplify it, divide by 3 both the sides. So x plus 2y equal to 4. Now let us see x and y, some points we can find. Let's say when x is 0, how much is y? 2. And when y is 0, okay, y is 0, then x is 4. So let us mark these points. 0, 2 comes out to be here. 4, 0 comes out to be here. So easily you will observe that, what will you observe actually? You will observe that this line actually goes something like this and they will intersect here somewhere, okay? And that exact point will only be clear in an actual graph. Right now, we can't know what this point is because this is not an actual graph. So I don't know what are the coordinates of this point. But when actually you will solve it, you will easily be able to find the solution by finding the coordinates. Obviously, since these are intersecting lines, it is a consistent system with unique solution, or we can also say it is an independent system, right? So that's it. That's the way we'll solve the third question. Now, talking about this question, let's say, by graphing, how to solve this. This is also very easy. So let me illustrate how to solve this question. All right. So let us consider these equations. 3x plus y is equal to 9. So how do we plot the graph? We can just find any 2 points which satisfy this equation and then join them to make the line, which will be the graph of this equation, right? So if I put x equal to 0, y comes out to be 9. If y is 0, x is 3. So very simply, we can just mark these points, for example, where is 0, 9? It will be here somewhere, 0, 9. Where will be 3, 0 point? It will be here somewhere, 3, 0. So if you join these 2 points, you will obtain the graph of this line L1. Okay, let's say this is the line L1, then this is line L1's graph. Okay, now look, let us talk about this equation. 5x plus 4y, 22. 5x plus 4y equals 22. So x and y maybe you can put here. So can you think of some values here that we should put so that we get integral points, so that it is easy to mark on a graph also? By the way, you can put any points. Like if you put x equal to 0, y you will get 11 by 2, 5.5. So that is also fine. Okay, but I was thinking if we can find integral points, it will be a little bit easier for us, right? So it doesn't seem like we are able to do that. So maybe if we put x equal to 2, yeah, x equal to 2, what are we getting? Y. 22 minus 10 is 12, so y is 3. So yes, this point satisfies it. Then what else can we say? Maybe we can put x as 6. Okay, x as 6, and then y we are getting minus 2, correct? So where are these 2 points? 2, 3 will be probably here somewhere. Just a second. Yeah, 2 comma 3, actually it will be exactly here, which is quite surprising. And 6 comma minus 2 will be here. Okay, so 6 comma minus 2 will be here somewhere. And let us say you want to write any one more point just for your satisfaction. So okay, you can put x equal to 0 and 5.5 y will come out to be. So where will be 0 comma 5.5? Well, it will be somewhere around here, right? 0 comma 5.5. So anyway, you can join these 3 points and it will come out to be a straight line. Okay, and you will observe that they intersect at this point, which whose coordinates happen to be 2 comma 3. So what is the solution then? X is equal to 2 and y is equal to 3. Okay, I hope this is clear to everyone. Now let us also have a look at this particular question. 3y plus 2x is 6. 3y plus 2x is equal to 6. And by the way, if this is line L2, then this is the graph of L2. Okay, this line. Now let us talk about this one. 3y plus 2x is 6. This is line N1, let's say. So let us find any 2 points which satisfy this. So when x is 0, y is 2. When y is 0, x is 3. So where are these points? 0 comma 2, which satisfies this equation, lies here. 3 comma 0 will lie here. Join both of these points. So clearly this represents line L1. Okay. Now what about L2? 5y minus 2x 10. So clearly we can observe that when we put x as 0, y is 2, then when we put y as 0, then x is minus 5. So where is minus 5 comma 0 point? Here it is minus 5 comma 0. Where is the 0 comma 2? It is here only. So when you join these 2 points, you will get the line L2 also. So obviously where do both of these lines intersect? At the point 0 comma 2. So x equal to 0 and y equal to 2 will be the solution. Correct? So that's pretty much it. We have solved them using graphical methods and we have got the correct answers as well. So that was pretty much it about this lecture, and I hope you all found this interesting and got to learn something new, and especially the topics that we covered were clear to all of you. So once again, thanks a lot for watching and stay safe and enjoy.